Okay, these notes are Charles's law notes. Okay, Jacques Charles, a French physicist, studied the relationship between temperature and volume in gases. He found that as temperature increased, volume increased. So Charles' law states that the volume of a fixed amount of gas at constant pressure varies directly with the temperature. Okay, let's look at example 1. A helium balloon in a closed car occupies a volume of 2.32 liters at 40 degrees Celsius. If the car is parked on a hot day and the temperature inside rises to 75 degrees Celsius, what is the new volume of the gas? Well, just like we did with Boyle's law, you need to define the variables. So we're looking at V1 and T1, and then I'll write V2 and T2 next. V1 is 2.32 liters. Now, T2 is not 40. We have to add 273 to it. And we get 313 Kelvin. Okay, and I'm going to put the next ones in black. Volume 2 and T2. So V2 is what we're looking for, and T2 is 75.0. And that one is 348. Okay. So we're still going to use the V1 over T1 equals V2 over T2. We really don't need to rearrange the variables. Because it's set up as a proportion, we're going to cross multiply and divide just like we would a proportion, because that's what this is. So we're going to put it as 2.32 divided by 313 equals V2 over 348. Now, when we cross multiply, there's a little trick to this. What we're going to do is we're going to multiply these two and then divide by this one. So it's going to be 2.32 times 348. So when you cross multiply, you actually get 2.32 times 348, and then you multiply the 313 by V2, and in order to solve for the variable, you end up dividing by 313. So it's just easier to, the two numbers that are across from each other, you multiply, and then the one that's left over, you divide by. When you do that, you get 2.58 liters. Okay? Okay, example 2. A 415 milliliter sample of argon gas has a temperature of 29.5 degrees Celsius. If the temperature is increased, the volume of the gas increases to 635 milliliters. What is the new temperature in degrees Celsius of the argon gas? So at some point, we're going to have to convert from Kelvin back to Celsius again for our final answer. Oops. Okay, so our V1 here is 415 milliliters. Our T1 is 29.5 plus 273, which gives us 302.5 degrees. Well, that's not degrees, sorry. Get carried away with my degree signs. And it's Kelvin. Okay? Now, V2 is 635 milliliters, but T2 is unknown. So, we're going to do it 415 over 302.5 equals 635 over T2. Now, when you're working out these problems, you don't have to show the next part. It would be nice if you did, then I could see that you cross-multiplied and divided properly, but for some of you, it's just easier in your calculator to go ahead and do it. As long as you have this, okay, as long as you have this set up, that's all I need to see, along with the variables. You have to define the variables also, so I know that you know which is which. That I know you know which one's V1, you know which one's V2, and all that. So you have to have these two things there. But that's it. Then you can just write the answer down at this point in time. Okay? I'm going to go ahead for those that are still kind of confused. We're going to cross multiply that. So it's 302.5 times 635 divided by 415 equals 462.9 degree. Oh, so that's Kelvin. Now, I want this in degrees Celsius, so I'm going to have to subtract 273 from it, and then I get 189.9 degrees Celsius. Okay? So hopefully you guys get this concept. It's pretty easy. It's kind of like Boyle's Law, only it's a fraction. It's a proportion rather than two things multiplying to equal each other. Okay, so we'll do a warm-up tomorrow, and then we'll work on some problems, and that'll be it. So I guess I will see you tomorrow. Bye.